Quando l'aria si espande adiabaticamente, la loro pressione P e il loro volume V sono connessi dall'equazione P per V alla potenza di 1,4 è uguale a C, e C è un costante. Presume ad un momento il volume è uguale a 400 centimeters cubed e la pressione è 80 kilopascals e sta diminuendo tasso di 10 kilopascals per minute. A che tasso è il volume a aumentare a questo momento? Okay, so we're going to start by writing out our givens. First, volume is 400 centimeters cubed. dV over dt is what we're looking for. P is 80 kilopascals. dP over dt is negative 10. The negative is important because it shows that it's decreasing. C is just a constant. So, dC over dt is 0. Now we're going to use the equation given to us, PV to the 1/4 power equals C, and take the derivative of it. Remember to use the product rule for the first half of the equation. Y'all know how to do this. I really don't need to explain this to you, so. This is just working out the product rule. And remember, the derivative of C is 0, so because it's just a constant. Now we're going to plug in the values that we listed as our givens before. Now we're just going to simplify this by doing all the multiplication and all of the powers. Okay, so we just skipped a few algebraic steps and divided over the coefficient of dV over dt. So the final answer is 3. Never mind that ain't chief, alright? 35.71 centimeters cubed per minute. And the for real final answer, because we're not done yet, is the volume is increasing at a rate of 35.71 centimeters cubed per minute. Didn't mess it up that time.
Yay, John!
This problem may be shorter than the other one in length, but there's a lot more to take in and there's a lot more to work with. First of all, we have two shapes that we're working with. We have a cone and a cylinder. So we're going to have volume equations for both of them. And we're also going to have separate equations relating the radius and the height of both of these shapes.
Le café se cuit dans un filtre conique dans une cafetière cylindrique à la vitesse de 10 inches cubed per minute. À quelle vitesse le niveau dans le pot augmente lorsque le café dans le cône est profond de 5 inches? À quelle vitesse le niveau dans le cône passe-t-il à ce moment?
In order to make all this information a little easier to comprehend and to deal with, we're going to start the same way we start any other problem, by writing down our givens. First, we're going to work with the givens for the cylinder, which is represented by the volume equation pi r squared h. Right? The givens for this cylinder are dv over dt equals 10 inches cubed per minute. We got this information from the fact that the volume dripping from the cone, that rate is the same as the rate at which the volume enters the coffee pot. Since the amount of coffee, the liquid, isn't changing, the rate is going to be the same as it goes from the cone into the cylinder. Okay, our next given is height. This is an unknown. Also unknown is dh over dt. The radius of the cylinder is 3. And this is a constant because the cylinder isn't changing and it's the same radius all the way from the top to the bottom. We're going to take all of the givens that we just defined and plug them into our volume equation for the cylinder. As of right now, the only one we can plug in is 3 for r. Just going to simplify this so it reads 9 pi h. Next, we're going to take the derivative of this equation. Now, remember, pi is a constant and not a variable, so there's no product rule needed. It's just a coefficient that you're going to put in the front. And now, we know dv over dt, so we're going to sub that value in. And then we're going to solve the equation for dh over dt. We're going to divide over 9 pi, and then write this as a decimal so it's easier to work with as we move into part B. And this decimal is 0.3536 inches per minute. Remember, this is just inches because it's height and not volume. Since this is a word problem, our final answer needs to be a sentence, and that sentence is: the level in the pot is rising at a rate of 0.3536 inches per minute, period. Now, moving on to part B. Or, not. Now we're going to do part B. This part is a little more complicated because we have two unknowns. So the volume equation is V equals 1/3 pi r squared h. The givens for this question are dV over dt equals -10. Yep, that's negative because it's decreasing. R equals 1/2 h. So we got this equation by comparing similar triangles. We got these triangles from looking at a cross-section in the cone. The height of the entire cone is 6. The radius of the whole cone is 3. The height of the coffee is 5. The radius of the coffee is an unknown. So now we know height for our coffee is 5. That's another important given. Okay, we're going to take the radius expression and plug it into the volume equation, so plug it in for r. This makes sure that there's only h's in our equation, so there's only things that we know or things that we're looking for when we take the derivative. So do some simplification, condense all of our numbers so it's nice and pretty, then take the derivative. We're going to skip a simple algebraic step and just condense that, the 3 and the 1/12 into 1/4, and then we're going to also plug in the numbers for our givens. We're going to use the -10, that's important, and the 5 for our h. And solve for that dh over dt. Skip some algebraic steps, just mostly dividing things over, actually just dividing things over. The answer is 0.509 inches per minute, and that's negative, because it's decreasing. Wait for it. There's the negative sign. Right? And it's a word problem, so our final answer is a sentence. Again, the level in the cone is falling at a rate of negative 0.509 inches per minute. Period. If you enjoyed this video, make sure to like and comment below, and don't forget to subscribe to our channel and turn on post notifications so you know when we post our next video. It's gonna be on integrals. Just kidding, we didn't learn those yet. Bye!